All right. So, the first night I talked about legacy of a human connection that we have with the human connection to the sky, and of course our ancestors had no idea whatsoever what they were looking at. I mean, not the foggiest idea, but they found it utterly fascinating and powerful because it would literally tell them it was connected to the biology of the planet as they knew it. When to hunt, when to plant, when to sow, when to pick up and move, and so forth. When it was going to get cold, when the days were going to be long, and when they were going to be short. So they knew it was important, and they studied it, and hence the first science was born out of that study. And the priest and the priest and the scientist were one and the same, and they were astronomers. But now we know a whole lot about what we're seeing. But unfortunately, we can't see it anymore. The knowledge has given and taken it away with light pollution. This is a chart that shows the so-called Bortle scale, which was some fellow created this scale to measure or to judge the degree of light pollution. And a lot of people will say, "Oh, well, I live out in the country, so I have a dark sky." Well, no, you don't. You have a darker sky than I do, but you probably almost certainly don't have a really dark sky. Typical rural sky is more likely to be a Bortle 4, which is not shown here. You're really out back if you've got a Bortle 3, and there's no place in Arkansas darker than a Bortle 2. There's no naturally dark sky place, truly naturally dark sky place left in Arkansas. No place where there are not sky domes that can be seen. So, which we can get close with a Bortle 2, and a Bortle 3 is a very nice sky these days in Arkansas. So one thing we have to do is, and by the way, this illustrates how fast this has come on us. It starts in the 1950s, and then jumps to 70s, and then the late 90s, and then projects on into the future. So this is a phenomenon that's very recently come about, and it continues to get worse at a rate of about 2% more light pollution every year. And you can see down in here where my cursor is, Memphis is here, and there's Little Rock, and you can see the Ozark National Forest and the Ouachita National Forest are the darker areas in the state, and that's shown on this map. And so when you want to go and find a dark sky, you want to go to this map site right here, www.lightpollutionmap.info, and you can get a map like this. This is Little Rock here, Memphis over on the right, Springdale, Fayetteville, all this up here in the upper left, Fort Smith. So you can find your way around, and you can see here the Ozark National Forest area up here is fairly dark, and the Ouachita area down here, and then what is this? I forget what this is called down here, but it's a river basin. I need to look that up, don't I? Or where the really dark spots are. So you can find this, and then you can think of a campground or something. If you want to really get a dark sky place, or a churchyard, a rural churchyard, something like that in one of these places. We maintain a map. ANSA maintains a map of places where star parties are held, or where you can find dark skies that you can observe from that are commercial, usually cabins, lodges, and campgrounds. So that's what this is. And the little numbers in here are the Bortle scales. So this is Bortle 3, Bortle 2, and so forth. Bortle 4 up here. We only put the 4s on there if it's a star party. So that's the light pollution angle. But then, as we all are painfully aware at the moment, there's also the weather. And this is a great site to go to check the weather. So you've got a plan you're working on, an observing plan you want to execute. You could get on this site, and it'll go out quite a few days and give you an idea when you might be able to get out and observe. Now it looks awfully crowded, but you're able to pick your location on the map, and then this is for your specific location, wherever that might be. And of course, you've just got days of the week up here, and then all this is a very detailed forecast, and we'll go over it here in a second. And then a longer range, less detailed forecast that reaches out over a longer period of time. Now, on the detailed end, what you've got here is the cloud cover, transparency, and seeing. And if it's white like this, that means it's overcast, and that makes the transparency poor. And the seeing in this case is poor. If you go over here, that's average, that's good. This is exceptional. The dark blue is exceptional in the case of each of these conditions. Now you say, what's the difference between over the cloud cover and transparency? Well, cloud cover is just exactly what you think it is, but you can have no clouds and still have poor transparency. If you think about on a summer day in particular, when the sky is white in the middle of the day because it's so full of moisture and particulate matter, that's poor transparency. So usually winter nights have high transparency if it's clear. Summer nights have low transparency, even if it is clear. And the seeing, unfortunately, works the opposite way. Usually the seeing is good when the air is stagnant and the transparency is poor, like in the summer, often the case. And the seeing is bad if the transparency is good. So you rarely ever have a perfect situation for both of those conditions. And you say seeing, well, what is seeing? Well, it's the if you go out and you look and you see the stars twinkle, that's the seeing condition. The atmosphere is if it's bubbling and boiling, it's highly active, turbulent atmosphere. It's moving that light around, making it jiggle, and that makes the stars twinkle, come and go. It's not terribly important for looking at the stars, but if you're trying to look at a planet or the moon with some fairly high power, then the seeing becomes a real problem because you can't see the detail that you could see if it was steady. Not that big a deal for naked eye and binocular observers, though. So you don't need to get too concerned about it. But if you were to get into the telescopic realm, you'd want to know about the seeing. This next line. Yeah.
Let me just throw one thing in, and that is that for planets and the moon, the transparency doesn't need to be as good as the seeing.
Right.
That's not I ever had was not real good transparency, but good seeing. So planets and the moon, if you got good seeing, go out and look at them.
Yeah. Now, this is sunrise and sunset, this yellow line right here. So that's a sunrise, and then this is sunset. And this is white line is moonrise. So moonrise and moonset. And then they actually set forth the moon and moonrise and moonset times right down here in clock times, so you don't have to guess at it. And then the sun is up here, sunrise and sunset is set forth, on your clock time right here. But graphically, this is nice because you can see how the moon is shifting, and it's, whoops, that wasn't supposed to happen, shifting relative to the sun's position each day as you go along here. Then down here is temperature and humidity. And of course, the temperature is important just from the standpoint of your comfort and how you need to dress and so forth. And then humidity, that sort of relates to the transparency issue to some extent, but also, again, mostly important for telescopes, but maybe even binoculars. And that is you get a really high humidity dew point, where humidity is the same as the temperature, like right here and right here, you're going to have the risk of your optics doing up and here. So you need to be, that's the reason that's on here. And I don't know why that's jumping like that. So then this is just a key, cloud cover, transparency, seeing wind speed and direction. That's this right here, temperature and dew points. So this is where the sort of the key to the deal. And if this was live, it's not just a picture, you would move this in your cursor. Well, here it is. This blue line over here is the cursor, and that cursor is telling you what the cloud cover is at that point in time. As you move this across, this number will change down here, and the colors down here will change. So, dang it. Let's see. Oh, one more thing. This is this International Space Station. So this is telling you where when the space station is going to be in the sky. And then this is I forget what this is called. This line here, KP2, KP3, etc., KP1. That is a forecast for the oh Lord, the the aurora. There we go, the aurora. We don't have much concern with that down here. I don't. Some people say they've seen an aurora from Arkansas, but that's got to be a hell of an aurora. So now another thing you need to be cognizant of is your instrument, your eyeball. People, I hear people say, "Well, I went out to try to see the comet and I couldn't find it." Well, they probably couldn't find it because they didn't know that they need to let their eyes adjust to the darkness. It takes 20 to 30 minutes to fully dark adapt your eye, and any exposure to white light will undo that adaptation. Your eye adapts to darkness in two ways. Is the reason for this. One is, of course, is fairly rapid, and that's your pupil getting bigger or smaller, cutting the light amount of light coming in up or down mechanically, so to speak. But there's also a chemical process that goes on, and that's what takes time, and that's what's destroyed with a flash of white light. And then if you get into the telescope area, or maybe even binoculars, I've never tried this with binoculars, but your dim light, your eyeball's got two different receptors. It's got rods and cones, and the cones are what give you a high resolution color vision, and they are predominant in the center of your eye, and the rods are black. You only see in black and white, but they're extremely sensitive. They work well in low light conditions, and they predominantly out towards the edge, away from the center of your retina. And so it turns out that if you're trying to see something really faint, if you don't look right at it, but rather look just to the side of it, you can actually see it better, called averted vision. So that's some little tricks, dark adapt, and then use averted vision. And that works naked eye. Averted vision works naked eye. So you're trying to find a comet and you know where it is, and you find the stars that surround it where it ought to be, and you are dark adapted, then don't look straight where you think it should be. Look slightly off, and suddenly you may notice you see it. So then you've checked the weather, and you've checked, and you've got your dark sight, and you've learned how to use your eyeballs. But you need now an observing kit. And of course, you see these red lights. The reason for the red lights is they don't destroy your dark adaptation. So you need a red or amber light. And if it's in the summer, you may want some bug spray. If it's in winter, you want extra clothing. A lounge chair of some sort, or zero gravity chair, they call them, is wonderful. You got to think about comfort, something to drink, non-alcoholic, because that's not good for your night vision, by the way. So I've just got a little sack, and I stick all this stuff in it. I got my flashlights in it. I got my laser in it. I got an extra turtleneck in there, a wool cap I can put on, extra batteries, so forth. So you get yourself rigged up, and then you need some kind of chart. Now, if you bought Rocky's book, you've probably got everything you need. If you don't have it, and even if you do, this can be handy, and it's free, and you can download this from the internet and print it out. It's called skymaps.com, and they got a different one each month. And so the sky here is the way it will be oriented in the early evening. And then they summarize everything that's neat and of interest that's going to happen that during the month, right over here on the left side. And this is about all you would ever need as a naked eye or binoculars sky watcher. This, of course, is the Milky Way going through here, and the ecliptic that we talked about going across here, and then all the major constellations, and many of the deep sky objects that we'll talk about. Rocky will talk about in our next session, including some galaxies and nebulas and globular clusters and planetary nebulas and open clusters. All the major ones are on here that you might see. And then you go on the backside, and there's lots more information, including a glossary of terminology, some tips for observing the night sky. And then over here, a list of objects that are visible with the naked eye and easily seen with binoculars, and then some that require telescopes with a little information about each one of them. So these are handy dandy little deals that you can download and print off free. So now you need to learn how to use one, though. Let me go back here and show you this. You see how they've got the direction labeled here, east, south, north, west. What you do is you go out, and if you look north, then you want to turn your chart so north is down. If you look east, you want to turn your chart so east is down. Whichever direction you're looking, you turn your chart, turn that part of your chart down, and then that will line up with the sky. Right there, I've saved you a lot of frustration. So, of course, these days, they've got all kinds of apps you can get on your phone. And I don't know who said best, Sky Safari. I mean, I have Sky Safari and I like it, but I don't know that it's the best. I just never used anything else. It is good, but there's a lot of them out there. And I'm sure they all have their virtues, and a lot of them,
That's what I was
you
thinking.
you can hold these up at while you're looking at the sky, and they will rotate so that they orient automatically to where you're looking. Now, when you get into charts, if you start to get into deeper charts, you'll maybe start to learn about and want to use celestial coordinates. So over here on the right is just an excerpt from a high-end sky chart that many of the kind of sky charts that you might buy from a bookstore that are fairly detailed, and you can see that they've got the coordinates on here, and all this is the coordinate system is just the Earth's latitude and longitude projected onto the sky. So the celestial equator lines up with Earth's equator, and of course the North Star and the North Pole line up with Earth's North Pole, and so forth. The difference is, instead of having latitude and longitude, you have what's called declination and right ascension. And declination is just how far north or south you're going, like latitude, and then and that's in degrees, just like latitude is. So we're 35 degrees north on the Earth, and that's what's the zenith over our heads is 35 degrees north. Declination is straight over our heads because we're 35 degrees north on the pole on the Earth. And then the right ascension, instead of being in degrees, it gets a little confusing now, but stick with me. It's done in hours. Now, why is hours, you say? Well, because you're looking at a moving sky, right? The sky is moving, and at what rate does it move? It moves at the same rate time passes. By necessity, we have a 24-hour day, right? And the Earth turns 360 degrees in a day. So if you have an hour of right ascension, 24 hours of right ascension, each hour is 15 degrees. And every minute you turn, the sky turns 1 minute, and every hour it turns 1 hour of right ascension. In 1 second, it turns 1 second of right ascension. So it just ties into the fact that it's a process of time that converts. If you want to, you can convert it to degrees, like I say, because an hour, divide 24 into 360, what do you get? 15 degrees an hour. All right. So then this is a way, if you're out and you know the distance between something, like the pointer stars of the Big Dipper and Polaris, or that Polaris, you know it's 35 degrees above the horizon because you're 35 located here on the Earth, 35 degrees north of the equator. Then you can look to the north, and you can put your fist out there, and at full length, at arm's length, it'll subtend 10 degrees. And you can stack, in your mind's eye, you can stack your fist up 3.5 times, and you should have, if you're looking north, you should see Polaris right there, second magnitude star. And you can cover up, I may have said this last time, you can actually cover the moon and the sun up with your pinky finger, because they each subtend a half a degree, and your pinky finger will cover a full degree. So, there's handy little things for finding your way around the sky. It's just a little close-up of a sky chart. If you drilled into one, here you've got a star. We've talked about star magnitudes. We've talked a little bit about star names. Really bright stars have proper names. And of course, each culture over time have given the bright stars different names. I think Sirius has got that we know of. It's got like a dozen names, proper names, depending on what culture you're talking about. But these proper names have actually been adopted by the International Astronomical. What is it, Rocky? What's it called? That sets all this stuff up. At any rate, after the proper names, that just covers a handful of really bright stars. Then we go into using Greek letters. It's called a Bayer system. Johannes Bayer made a catalog of the bright stars. I think I'm trying to remember, just under 1,000 stars that he cataloged, and it printed up sky maps, high precision sky maps. So the first printing of that kind of thing, I believe. And he used this system of Greek letters to name stars that didn't have proper names. And then after that, you got Flamsteed numbers for dimmer stars, and there's an endless number of catalogs now. We keep creating new catalogs, and every time a new catalog is created, there's I gave a talk on this, star names, and you can get it. You can see it on CAS, Central Arkansas Astronomical Society's YouTube thing, and I think it's a lot of fun and worth watching. You might do. I'll send a link out after the program. And then you got little symbols in here for like this planetary nebula. Sort of looks like got a hollow star with almost like a little Saturn. And then this down here is a globular cluster. That's a symbol for a globular cluster. And that you'll be a key on your maps. Whoops, going the wrong way. So anyway, the Greek alphabet for stars. There it was, Johannes Bayer, 1603. So what did we learn? A little summary before I turn this over to Rocky. Star magnitudes. Each magnitude is 2.5 times brighter or dimmer as you move up and down the scale. And by the way, somebody asked why the number gets smaller as you get brighter. Well, Hipparchus is the fellow that created the first known catalog of stars, and the word magnitude is Greek, and it means size. And when you think about it, brighter stars look bigger than dimmer stars. And so he was just saying what the star size was. And so he started at 1, at 0. So the brightest star was 0 magnitude. And then you could see that how he might think of 1 being dimmer and 2 being dimmer still, and so forth, because they were a lower rank. You're going, but at any rate, that's obviously what he was thinking. I don't know. It seems counterintuitive, and at the same time, it seems to make sense. Star color, blue giants and red giants. Something is a function of temperature, and something we didn't mention is that this is also a function of the age of the star, where it is in its life expectancy. And giant blue stars are really bright stars that don't live very long. Then you go down to smaller stars that are in the main sequence. In other words, in their midlife stage, their principal life stage, like the sun is right now, and they just go to white to yellow to red as they get smaller and smaller and dimmer. But you don't see, I'm not sure you can see any red main sequence stars because they're so dim. You'd have to have a telescope or something to see one of them. When you see a red star, it's a latent life star, and it's a red giant. It's a big star, not a little star, but it's cool because it's expanded so much that it's cooled down, and yet you can still see it because it's so big. So you got 2 different kinds of red stars. It's the bottom line. Constellations and asterisms. We talked about that. Asterisms, just any pattern of stars in the sky that people are familiar with, like the Big Dipper or the Little Dipper. And sometimes those are the center part or the main part of what we recognize in a constellation. But a constellation is actually an area of the sky. Reading star charts, Greek letters, holding it up where you look where the direction is down, getting started using charts, planispheres, planetarium programs, use red flashlights, preserve your dark vision, create an observing kit, start with a circumpolar area around the North Star to orient yourself, find the current seasonal asterism and identify the brightest stars and learn their names. And then the little thing about the binoculars. And I'm going to turn it over to Rocky. Ooh, took hogged a lot of time, then I'm sorry. Oh, we started late, so I feel better about it. Okay.
You let me share my screen.
Yeah.
Okay.
Stop share. And I should have set you up where you can do that. There you go.
Okay. Okay. But before you go out, go out and look at the stars, it's fun to do a little planning on what you're going to see. Like you might be going out to look at the moon, or you might be going out to look at the winter hexagon, or just whatever your planets, measure your objects. But in the daytime, you can do your planning. I've always done a lot of planning before I went out, and sometimes it was at night, but a lot of times it was in the daytime when I'd print off charts or something like that. So it can be cloudy, or you can go ahead and start planning anytime. Then at your leisure, do a little map memory and memorization first. And one of the first things I did when I was a kid was learn the first magnitude stars, because they're your guide to finding everything else in the sky, to finding the constellations, to finding objects in the constellations, and to watch the sky, watch how the sky rises in the east and goes down in the west. And so take a little time to learn to spell and pronounce the star names and the constellation names. And the first time you go out, then you'll be tracing out some constellations, be able to name some bright stars, and maybe even find some deep sky objects with your binoculars. Another thing to think about before you go out is where you're going to observe. And it may be great if you've got a backyard you can observe from, where the lights are hidden. And there may be some place around your house. I like to observe from my house, so that's the first place to look, to see if you've got a good place. And even though you might have a few lights, if you can block them, it makes a lot of difference. And if you're looking at the moon or planets, the lights aren't going to hurt you very much, unless they're unless they're shining in your eye while you're trying to look through the telescope. But you can block that. Maybe I block mine with a car or by moving around the house. Which horizon do you need? I'm always looking for a good place for a horizon, especially east and west, because a lot of times, like Jupiter and Venus right now, a month ago, Venus was down near the horizon, and I didn't see it because I didn't have a good eastern horizon. I know where there was one. I could have driven to it, but I just never did it. But find some places where you've got a good horizon. And if you want to look at something specific, you might want to pick where you're going, to where that part of the sky is not blocked. But actually, one time I lived when I lived in Fayetteville, I had about a 20-degree swath above, east to west, above my house, and that was it. So I had to plan what I could see in that little section of sky. And I did a lot while I was up there. And you may want to find some places you can travel to. Like Bruce was talking about, a churchyard, or I had a graveyard that I used to sit outside it one time until they put a light up there. There's a good place here in Heber Springs, down near one of the parks in the overflow area, that I can go to. that I've gone to watch meteors a lot of times. Okay, I'm gonna fire up Stellarium now, and we're gonna talk about Stellarium. I don't know if anybody's had a chance. We gave it as a reference last week, but Stellarium is just an outstanding program. Let's see, I think, did that share Stellarium? Are you looking at Stellarium, Bruce?
I'm looking at slide Stellarium.
Okay, so I'm gonna stop share and share again. Okay,
There you go.
so I think I've got it right now, but there's a little symbol down here for now. So my time is right now. So you can see right now, Venus and Jupiter are pretty low in the west, but they're still up. If you click on, I'm going to just give you a little quick summary, some things to do in Stellarium, and hopefully you can download it. It's free to download. Just Google Stellarium, and usually I download it from a place called SourceForge. There may be a few different places to do it from. But if you click on like Venus, it gives you a lot of information about Venus, including how high it is in the sky, how bright it is right now. See, Venus varies in brightness. Right now, it's minus 3.92. Bruce was talking about, they started with 0. We've got one star that's less than 0. That's minus 1. Venus is minus 3.92. And let's see what Jupiter is. Jupiter is minus 2.09 right now. So that's right up here. And all this is different things that it tells you about Jupiter. You can do the same thing for any star. This is Hamel in Aries. Alpha, it tells you all the different star names like Bruce was talking about. Alpha Aries, 13 Aries, HIP, SAO. So those are all different star names. And another neat thing is it shows the color of the star. I don't know if you can see the color here, but this is yellow, kind of a yellowish star. Let's see what this one is. You can see that's a bluish star. That's Beta Aries. And Gamma Aries, if you've got a telescope, is a nice double. Nice little double.
And we haven't talked about double stars, but I'll just jump in here and do it. You know, the sun is all by itself. It's a star all by itself, but most stars that look like they're just one star. In fact, if you put a telescope on them, or sometimes even, well, a few you can tell it with the naked eye, but with the binoculars or a telescope, you can so-called split the star into its components. It's actually not one star, it's two stars in orbit around a common point of center of gravity. And sometimes there are 3 stars, and sometimes there are 4 that are mutually in orbit. And most stars, in fact, have companion stars. They're not by themselves.
I just clicked on the date thing over here. There's different functions you can click on. One of them's date, one of them's find, another one gives you parameters of different things. But I just clicked on the date, and we're gonna go back in time a little bit, just a minute at a time. And you can see Jupiter and Venus going back up. And if I keep going, you can see the daylight coming in too. So it mimics the sky. So you can kind of tell when what time you're going to be able to observe. So I'm gonna pop up to 7 o'clock, which would be 1900. So that's where they were about 7 o'clock tonight. Another thing we talked about the ecliptic. So if I punch a comma, and there's different functions, that shows you the ecliptic, and you can see Venus and Jupiter, Mars, and the moon are all close to the ecliptic, and they follow the ecliptic right here. I was gonna, I think, go forward. Oh, we were gonna talk about the northern sky. I was gonna I'll pull it around to the north. And I'm gonna go ahead and click on the constellation button so you can see the constellations. So this is Ursa Major, but you know it is the Big Dipper. And even though these are pretty bright stars and it's a neat constellation to trace out, the Big Dipper is what we're familiar with, the 7 stars there. And you can see it points directly to the North Star. So that's how you find the North Star. That's how we teach Boy Scouts to find the North Star, and whoever else. And I was gonna go forward in time and show you how it progressed. Okay, so this will be a 1 hour increments. So you see how it moves every hour. So that's midnight right there. And that's 5 in the morning. So it's gone halfway around, pretty much close to halfway around. Then as you keep going, it gets to be daylight. And right now it's down in the daytime, it's down near the horizon. But now if I go back and click that now symbol, okay, there's where it is right now. You can see that some of the other constellations that are around the North Pole. Here's the Little Dipper or Ursa Minor. The other two, there's 3 more constellations that are worthy of learning, and that's Cassiopeia that CJ said she saw, I think, Cepheus, which is kind of dim, but it's a neat constellation when it gets high in the sky, and it'll be up in the late summer and fall in the evening. Of course, you can see all these at some time during the night high in the sky. Another neat one to trace out is Draco right here. Draco the dragon. Okay. What else are we going to do with this, Bruce?
Well, I don't know. I was just going to say that, and maybe we touch on, is Andromeda up there right now?
No, but I'll go ahead and I went forward an hour at a time. I'm going to go forward. I think, let me check and see if this is, okay. That's a week. Okay, so this is a week at the same time of night. So you see how it's moving they're moving to the west. And so this is about 9 o'clock at night. So you can see about 9 o'clock at night, Sirius is going to be setting in the west. And you're bringing up a whole new section of the sky here, and we'll be talking about it in future weeks. But this is the spring constellations with Leo and Virgo and Boötes and several more. This is Hydra with and this Hydra's got some bright stars and a real neat the head of Hydra right there. Crater is very dim. Corvus is real bright, pretty bright constellation, but we'll get into those as we in the weeks to come. And then you keep going, and now it's summertime's caught up, and it's still light at 9 o'clock. So that's June the 1st. So I've got to go to 11 o'clock now, and
if you can get Andromeda up, I don't really need it. But it would be good.
These are the summer stars with Sagittarius and Scorpius, which are, and then the summer triangle here with Cygnus, Lyra, and Alta, Aquila. There you go. Okay, I'm coming to Andromeda. And then in the fall, you've got the square of Pegasus and the Clash of the Titans, if you've ever heard of that. Now, if I click on Andromeda here. So there, okay, Bruce, there's Andromeda.
Okay, that's our nearest major galactic neighbor, a little over 2 million light years away. You can see it naked eye under a dark sky, which is really fascinating when you think about it. Something that's over 2 million light years away, and you can see it with your eye. But it is a big galaxy. It's our nearest major galactic neighbor, and it subtends 6 degrees in the sky. No, yeah, is it 6 degrees? 6 lunar diameters, 3 degrees.
Yeah, 3 degrees.
3 degrees, 6 lunar diameters in the sky. If you could see it all, you can't, of course, with the naked eye. All you can see is the core of it.
But with the camera, you can see the whole thing.
Yeah, you get a good pair of binoculars and you can start to see the whole thing. But now swing around. What I really want to do is a lot of people really enjoy the storytelling, mythology that goes with it. And so,
Oh, yeah.
yeah. So if you could get Cepheus back in, yeah, you've just about got it. Cepheus and Cassiopeia. There we go.
Okay.
So, yeah. So, Cassiopeia was the queen of Ethiopia, and Cepheus was the king in the mythological stories. And Andromeda, which is this not the galaxy, but the constellation Andromeda right here.
Right here.
Yeah, right here. It's usually drawn with 2 arms. This one only draws it with 1 arm. But Andromeda was their daughter, and Cassiopeia was overheard claiming that she and her daughter were more beautiful than the sea nymphs. Well, the sea nymphs didn't take kindly to that, and they complained to Poseidon, the god of the sea, the lord of the sea, and he became angry and threatened to destroy the kingdom of Ethiopia. And the only way that they could avoid the destruction of the whole country was if they agreed to sacrifice Andromeda to the sea monster, Thetis. Yeah, down here, it's where Cetus, the sea monster. And so they chained Andromeda to a rock so the sea monster could come and devour. And was it Hercules?
Perseus.
Perseus. Yeah, I didn't think it was Hercules. I was trying. Perseus. Perseus was. There's Perseus. Perseus just happened to be flying by on
Pegasus.
Yeah, was it on Pegasus or his winged sandals? I don't remember which, but at any rate, he was on his heroic adventures and was coming back from having slain the Medusa, as I recall, and happened to see her chained on the rock and the monster coming, and he slew the monster and saved Andromeda. So
there's Medusa and Algol.
Yeah, so the sky is full of these stories, and in the first night I mentioned to you that it was our ancestors' Netflix, because they hung their stories of their gods and their villains and their heroes on the patterns they saw that illustrated in the sky. And that's just an example. So we have covered what we wanted to cover tonight. How about question time?
Okay, I have a quick question.
Yeah.
If you're using an app to, orient yourself in the sky, does that interfere with your night vision? Is that considered even if you've got it on a dark screen?
Most of these apps have a night vision feature, and so the light is red. Everything is that's illuminated is red.
Okay, I don't think mine does it? I'll have to look at the one I have.
Yeah, look at it and see. Now, and it may not be default that way because you might want to see it in the daytime, and if you see it in the daytime, you might want all the colors, whatever it's going to give you in the way of a pretty picture. But I'm pretty sure, certainly should have a night view
Okay.
that you can turn on, and so you may have to go into the settings and turn on the night version.
Okay. I'll do that. Thank you.
Hey, Bruce, let me go through, the moon is up this week. Let me go through the moon real quick.
Oh yeah, that's right. We were about to forget that.
Yeah. So if you got binoculars, and this is a good activity for this week, is to take a good look at the moon. And there's different features on the moon. There's highlands, which is this white area right here. And then there's they call it lowlands, but it's actually these seas, the mares, which are lava-filled craters that were filled with lava. I'm not going to get into the more observing the moon tonight. And then, of course, you've got craters, which all of you have heard of, and that's some of these spots here, and rays. And rays are mostly visible during the full moon. And if you look at the full moon, or even right now, you can see some rays because the moon's is in the gibbous phase right now. And they're from new craters and they haven't deteriorated yet from little bitty the little bit of activity on the moon over a billion years will deteriorate. This crater right here is Tycho, and you can see the rays coming out of it. Well, it's about 800 million years old, and the rays are still prevalent. A lot of these other craters don't have rays, and they're in the 3 billion year old, 2 billion to 4 billion, 4.5 billion. The moon is about 4.5 billion years old. Talk about map memory again. I like to try to memorize some of these things. And last week I talked about the Lady in the Moon. And what does that have to do with map memory? Well, a lot of the most prevalent seas on the moon, which are the easiest thing to see with binoculars, make up the hair of the Lady in the Moon. And you can see her hair right here. And this is the bun on top of her head. And then here's her eye, her nose, her mouth. And once you see her, you can't unsee her. When you see the moon, you'll see the Lady in the Moon. And down here is Tycho is kind of a bright brooch that she's got on her neck, or a necklace, I guess you'd say. But memorize the names of these seas and go out and look at them. And I've got a list of the main things here, and there's not very many. Chrysium, which one of the newest seas on the moon. Fecunditatis, Tranquillitatis, which is where Apollo 11 landed. Mare Serenitatis, Mare Imbrium, which is this mare right here, which has got a lot of interesting features around it, where when it crashed, it pushed up this mountain chain here. Mare Fregosus, which is the what it sounds like, it's at the I think that's the South Pole. I don't remember North or South Pole, but it's a Fregosus. That's why they named it that, is because it's close to one of the poles. And then a few craters that you can see with binoculars. Tycho, especially when it's near full moon, stands out. I don't see it right now. It's right in here. I'll show you on the next slide. Plato, which is a dark crater kind of in a white area right here that's fairly easy to see with binoculars. Copernicus, which is one of the most spectacular craters on the moon, especially with a telescope, but you should be able to see the rays coming out of it. And Grimaldi is the other one I've got, which is a lava-filled crater right here that's easy to see because it's in kind of a white area. I was looking at the moon the other night, and Clavius right here is a crater you can actually see naked eye when it's on the terminator. And the terminator is the is the part between light and dark. I've got a slide on that in a minute. So you can see most of those things with binoculars, all of those. And once you learn those, you can find just about anything you want on the moon. And this chart is kind of right side up. I sent it to you last week, I think. And here it is without. Now, can y'all see the lady in the moon? Right here. She stands out with binoculars on the moon, especially with the gibbous moon, when the moon's just about right here. And here's a younger craters are bright. And this is Aristarchus. It's a little bitty crater, but it's the brightest spot on the moon. Another bright one is Tycho right here that's got the rays coming out of it. You can see it better on this. And here's Copernicus. Those are all young craters, less than a billion years old. And best place to observe features, especially with a telescope, is on the terminator, near the terminator, because you get shadows there just like you do if you go out at sunset and you look behind you, you've got a long shadow. And those long shadows is what you get on the edge of the terminator, and you can see the shapes of mountains and things like that. You can see features a lot better. And I'll send this out to you, but this is just some suggested activities. Put your observing kit together, find an observing site, check the weather. And I talked about the moon progressing from gibbous to full. Note the dark areas, look for bright areas and the rays. Watch how the moon progresses across the sky. I meant to show you that on Stellarium, but it's too late now. Find the lady in the moon, and then when it's full, try to see the rabbit in the moon. And on clear nights, go out, even if you just go out for a minute, watch Jupiter and Venus his dance in the western sky. That's just amazing to me. I never get tired of it. And then red Mars is right straight up above you. And if you kind of watch it, kind of note where it is, you'll and look at it every week or so, you'll see it moving through the stars. Find the Big Dipper and the North Star, and I think I sent you that chart last week. If you're up late, I'll show you next week how to find Arcturus using the Big Dipper. Retrace out Orion and the Winter Hexagon. And with binoculars, if you got binoculars, look at the Pleiades and the Orion Nebula, and also the Hyades and Aldebaran, and they're all on the map I sent you, and they're all visible even with the bright moon. Okay, Bruce, that's all.
Okay, I'm glad we caught that out. Didn't forget it. So, any questions?
Bruce, I have one question.
Sure.
When you were looking at the dark sky maps earlier, we talked about the boreal of 1, 2, 3, and 4 as far as the darkness. Is there an app or something that tells you how dark the area you're at, or how can you tell that far as the as far as the range of 1, 2, 3, and 4, 5, 6, and 7?
But how can you find out what kind of sky you got?
Right.
Okay. There are several ways to do this. One is to go to that map, that light pollution map I showed you. And if you click on that in a particular location, it'll tell you what the Bortle scale is at that spot.
I've done that, but I haven't yet to see that. So I guess I'll have to sit and play with it some more.
Yeah, you just click on the map and it'll give you the Bortle scale and the sky brightness. I find it's a little optimistic. I think it's a little optimistic. Another way to do it is if you will Google Bortle scale, you can find some sites that go into detail about what you should be able to see at under each of those Bortle levels. There's a a fairly graphic description of what you can and can't see. So you can go at your sky and see what you can see and make your own subjective judgment as to what Bortle scale sky you've got. And then the third way we're going to talk about on the fourth week is to go to this website, what's it called? Oh Lord, I don't know. Well, we'll cover it anyway. But at any rate, this website is its whole purpose is to get people to go out and view their sky and determine, using the charts they give you, determine what your limiting magnitude is, and then report that. And the reason they want you to do that is that the lighting technology is changing, and the way they build that map, that light pollution map, is through using satellite data. The satellite data was not intended to measure light pollution. It's for other purposes, but they figured out how to adapt it so that you can create and track light pollution over the whole globe using satellite data, but it has to be calibrated. And so with the light technology changing, with basically the adoption of LED, they need people to go out and measure their sky and report it. And so this is a citizen science project. And we're going to talk about how that works and how to do that, and hopefully get people to do it. So
Okay.
there's 3 ways I know of that you can determine your light pollution level and the Bortle scale.
I think you can actually plug in your coordinates, but you can find them on the map. And then when you right click, it gives you this little chart, and that'll tell you what they think your Bortle scale is, and your SQM reading.
Yeah, and the SQM reading is basically what that means is when you say that it's the SQM is 22, which is as dark, in theory, a totally dark natural sky, like if you're in a high desert in Chile, would be a 22 sky. And that means that the natural brightness of the sky is equal to if there was nothing up there but 22nd magnitude stars in each square arc second. It's pretty dark, because the dimmest thing you can see with the naked eye is under the ideal conditions with ideal eyesight, is some people claim they can see 7th magnitude.
All right, thank you, Bruce.
Yeah. Anything else?
Have a moon question.
Yeah.
How big of a telescope would I need to be able to see one of those lunar landers we left up there?
I think you could use a small telescope, but you'd have to be on a spaceship.
Good answer. Good answer.
But you can see where they landed. You just can't see.
Yeah.
Yeah.
One of our members just sketched Apollo 15 and Apollo 11 landing sites.
Anything else, guys? All right. See you in a week.
Thank you.
Thank you. Thank you. Thank you.
Thank y'all.
Thank you.